Hi, my name is Edgar Aguirre and this video is about biofuels, specifically hydrogen generation.
Hello, my name is Ricardo Flores. Introduction. The use of fossil fuels is generating change in the environment and causing health problems. In the same way, exploding the oil fields. This could be reduced if alternative fuels are used. The objective of this project is to realize a nitrogen cell for the generation of an alternative fuel. Water electrolysis. In the electrolysis of water, electricity is used to decompose water into its elemental components, hydrogen and oxygen. Water electrolysis is often considered the preferred method of producing hydrogen, since it is the only process that does not need to be based on fossil fuels. Using this method, in addition, we will obtain a final product of high purity and is feasible at both small and large scales. The device that is used to carry out the electrolysis of water is an electrolysis cell, which consists of a series of cells, each with a positive electrode and a negative electrode. The electrodes are immersed in electrolyte to facilitate the migration of the ions. The anode positive electrode is generally made of a nickel and copper and is coated with oxides and metals such as manganese, tungsten, and ruthenium. The cathode negative electrode is generally nickel coated with small amounts of platinum as a catalyst. Without the catalyst, the active hydrogen will accumulate in the electrode and block the flow. In this video, we can observe the mixture of water with different electrolytes, mostly bases, which are caustic soda or sodium hydroxide, cal or calcium hydroxide, and salt water. In turn, they tested copper and stainless steel electrodes against common steel electrodes with each of the aforementioned solutions. The tests carried out with each electrode and each solution were electric conductivity test, hydrogen production flow, and the state of the solution over time.
Hello, I am Adrian Ortiz and I will explain this slide. Um, well, after we determine the electrodes and so on the solution in which the cell will function, we proceed to do the design and the assemble of the hydrogen cell. As we can see in this slide, we are manufacturing by cutting and holding the inoxidable steel parts, and also we are assembling the cell. And well, here is the final product or the final assemble of the hydrogen cell. As we can see, our hydrogen cell has three pipes, two at the top and one at the bottom. The two ones at the top, one is for the output of oxygen and the other for the output of hydrogen. And the one in the bottom is where the solution enters the cell.
In this series of photos, we can see the finished physical prototype. Obviously, there are still things to improve to have a higher production and an effective system.
Well, in this video was one of the first experiments we made, and well, in the beaker we have caustic soda, we have 200 grams, and it gave us a 5% concentration in 4 liters of water, which is approximate the capacity of the hydrogen cell. And then we only mix it and it's ready to enter the cell as the electrolyte.
In this recording, we can observe how the system is deficient, since it loses the mix used to perform the electrolysis in the generator, as well as the leaks that are generated because they generate a very small element that is difficult to contain due to its size. The PIP system is the main problem, since the budget was limited, but it is planned to improve over time.
Hello, my name is Santiago, and in this video I will explain how the safety circuit that we elaborated works. We feed the generator with a car battery charger, which feed with 12 volts and 10 amps to our generator. In our circuit, we use a screen that shows the voltage and amperage that the generator is consuming, as well as we use a fuse and a relay to prevent short circuits. Here is shown how the bubblers are filling in order to turn on our generator. The liquid that is being introduced in the bubblers is conformed by water and caustic soda. Since we have the system filled with water, now we can turn it on and check how many amperes and voltage is consumed. Here we have the system running, which is consuming 12 volts with 8 amperes.
As you can see in the video, we are filling all the bottles so the caustic soda can be in the pipes and we can begin the experiment. So with this video you can have an idea of the pipeline and some of the elements of the safety system that we have in our generator. After we introduce the caustic soda with the water, we generate the electrolysis with the help of a 12 volts battery, and we can we can separate the oxygen from the hydrogen. So another important thing to mention is the safety system that compose our project. These elements are electronic elements that are the relay, the switch, and the breaker. And these elements works as a protocol to prevent some failures or damage to the user. So if there are ups and downs on the volts or amperes, we can prevent an accident and keep the safety of the user. So with that clear, now we can proceed with the conclusion and the results that came from this project.
We can hear how the generated hydrogen explodes. In this table, we can see the parts per million of hydrogen generated during a period of no more than 1 minute. Thanks.